It's Shubhamangalam at Legal Scholar. Myself Sukdeep. I'll be taking up class 9 physics, and we will continue with chapter 2 motion, and we are left with just 3 pages which are very simple. So we are on page number 25 and we have a very simple activity over here. The aim here is to find the acceleration and velocity of an object moving on an inclined track. So everybody knows how does an inclined track look like? Something like this. Okay, so where do you find these inclined tracks? Usually in parking lodges or somewhere near hospitals, so that the people on wheelchair can move easily up into the hospital. That's just an example over here. So yes, we are. Please open up your textbooks and come to page number 25. So, the lab activity aim here is to find the acceleration and velocity of an object moving on an inclined track. What is acceleration? Acceleration is the rate of change of velocity, the how much the velocity is changing at a particular instant. What is velocity? Speed in a particular direction, yes or no? So, yes, the materials required are glass, marbles, book, digital clock, long plastic tubes and steel plate. I repeat, the materials required here are glass, marbles, book, digital clock, long plastic tubes and steel plate. So basically you are going to use the books, okay, and you're going to use the steel plate so that you are able to build an inclined track, just like shown in the figure number 18 over here. So you're going to take a long plastic tube of length nearly 200 centimeters and cut it in half along the length of the tube. So half of 200 centimeters is going to be 100 centimeters. Okay, you're going to take a 100 centimeter long tube and just cut it. Sorry, you're going to take a 200 centimeter long tube and cut into two halves, which is 100 centimeter and 100 centimeter. Okay, use these two parts as tracks. So basically this track that you see over here is 100 centimeter and 100 centimeter of a plastic tube. Do you understand? And it is balanced with the help of some books over here, and at this end it is balanced with the help of a steel plate. Okay, so now let's see. So use these tube parts as tracks. Mark the readings in centimeter along the track. So you are going to mark the readings on this particular tube with by starting from 0 over here, like it is 20, then it is 40, then something like 60. Okay, just a random I've done a random marking. You can definitely use a scale. So mark the readings in centimeter along the track. Place the one end of the tube on a book and the other end on the floor. One end of the tube is placed on the books over here and the other end is placed on the steel plate which is on the floor, just for some support. Okay, keep a steel plate on the floor at the bottom of the track. So what is going to happen over here? If I release anything from this particular point, which is going to go down the inclined plane and reach the steel plate, so you will be able to hear a noise, yes or no? As soon as if I throw a ball from this end which is going to roll down the plane and fall and strike the steel plate at the bottom, you are definitely going to hear a sound. As soon as you hear the sound, you can mark the readings or mark the time. Do you understand? Let's see further. Keep a steel plate on the floor at the bottom of the track. Consider the reading at the bottom of the track to be 0. At this particular point, the reading is going to be 0 class. Okay, take a marble having an adequate size to travel in the track freely. Now release the marble freely from a certain distance, say 40 centimeters. So you are going to take a marble and hold the marble at this particular position, and as soon as your digital clock is ready, okay, it is at 0, you are going to release the marble, and as soon as you release the marble, you start the digital clock. Do you understand? And as soon as the marble strikes the steel plate, you are going to stop the clock. And what do you do with this? You are going to note down the timings. How much time did it take for the marble to reach the bottom? That is what you're going to observe over here. Okay, now look over this. Now, okay, start the digital clock when the marble is released. It moves down on the track and strikes the steel plate. Stop the digital clock when a sound is produced. When is a sound going to be produced? When the marble is going to roll down the plane and reach the steel plate. As soon as it strikes the steel plate, it is going to produce a hard sound. And as soon as you hear the hard sound, you are going to stop the digital clock. Okay, repeat the same experiment for the same distance 2 to 3 times and note the values. Repeat the same experiment for various distances also, and do the same experiment for various slopes of tracks and various other substances. Let's see what are we actually trying to understand over here. So the aim here is to find the acceleration and velocity of an object moving on an inclined track. All of us know what is an inclined track. Yes or no? I've drawn a rough diagram over here. How would an inclined track look? Something like a seesaw. No, like a slide. Yes or no? You must have seen in your parks that you sit over here and you slide down. It is just an example of an inclined plane. Do you understand? So here you are going to build your own inclined plane with the help of some books, a steel plate and some plastic tubes. Do you understand? So the length of the plastic tubes was 200 centimeters, and you're going to cut it into half. This means when you cut it into half, you get 200 centimeter tubes, and you're going to put those 200 centimeter tubes onto the books and with the help of a steel plate, and you are going to build an inclined plane over here. Do you understand? And you're now going to mark the readings. So at this particular point you're going to mark 0 centimeters, and starting from here the other readings are marked for, say for example, let's say this is 20 centimeters, 40 centimeters and 60 centimeters. So now you are going to take a marble and you're going to hold at the 40 centimeter point, and you're going to keep your digital clock ready. What is a digital clock? The stop clock class. Do you understand? And here at 0 centimeters near this particular point, I have placed a steel plate. Okay, why have I placed a steel plate? As soon as the marble is going to strike the steel plate, I am going to stop the clock because I'm able to hear a sound. What does the sound prove? That the marble has reached the finishing point. Do you understand? So I'm going to release the marble. As soon as I release the marble, I start the stop clock. Okay, the timer has already started, and this marble is going to roll down and reach the bottom and strike the steel plate. So let's record the time over here. Let's have some exemplary timings. For example, the first distance at which I started releasing the marble ball was 40 centimeters. I have recorded three different timings from the same distance. I do it once. Again, I bring the marble at 40 centimeters. Again, I start the stop clock and again I release it. Do you understand? This I am going to repeat this for the same distance 3 times. For example, I got 2 seconds, 2 seconds and 2 seconds as the three different times over here. Not same, different, it is going to be the same time. Like just an example, okay? I released the marble from 40 centimeters on the inclined plane, and it completed the distance and reached the finishing point by taking how many seconds? 2 seconds in all the three cases. So what is the average going to be? The average is also going to be 2 seconds. Yes or no? Hope you know how to find out the average. The sum of the numbers by number of the numbers. Yes or no? So 2 plus 2 plus 2 divided by how many numbers are there? 1, 2, 3. Yes or no? So 2 plus 2 is 4, 4 plus 2 is 6, 6 by 3 is equal to 2. Do you understand? So the average time is given as 2 seconds. Now I need to find out the acceleration. How did I get this 2s by t square as the formula for acceleration? You remember we had s is equal to ut plus half at square. This was one of the formulas that we were studying in equations of motion, the previous video class. Please refer the previous video for this particular equation. S is equal to ut plus half at square. S stands for displacement, u is the initial velocity, t is the time taken, and a is the acceleration. Do you understand? So here, what am I going to do is, the initial velocity is going to be 0. Do you understand? So in place of u, I am going to write 0. 0 into anything is also going to be 0. So what am I left with? S is equal to 0 plus half at square. I need an equation for acceleration. So what am I going to do? So this 2 comes on this side. It becomes 2s, and t square is also going to come in the denominator. 2s by t square is equal to acceleration. Do you understand? This is what I've written over here. So the last column that you see in your book on page number 25, table number 4, the last column is written as 2s by t square. This means you need to find out the acceleration over here. Do you understand now? So how do you find out the acceleration? You're given 2s by t square. What is the s value over here? 40. So 2 into 40 divided by t square. How much is the t value? 2. So 2 square is equal to 4. So 4 ones are 4 tens are. How much is the acceleration? 20 meters per second square. Do you understand? The acceleration of the marble rolling over the floor. Do you understand? At a particular, from a particular distance. What is this particular distance? 40 centimeters. What was the average time? 2 seconds. Do you understand now? So now what do I need to do next? I need to change the distance. I am going to change the distance to 60 centimeters. And for example, to cover 60 centimeters, the marble has taken how much time? Let's say 3 seconds in all the 3 cases. So what is the average time going to be? It is also going to be 3 seconds. Do you understand? And thereaway we can also find out the acceleration. But what point are we trying to prove over here? But what point are we trying to prove over here? Let's find it out. Okay, let's observe by plotting it in a graph. So all of us know how to draw distance versus time graph. The time is going to be on the x-axis and the distance is going to be on the y-axis. So this is the origin point. So now I am going to write it as 1, 2, 3, 4 and so on. And here 20, 40, 60. Okay, so at 2 seconds the ball covered 40 centimeters. At 3 seconds it is going to cover 60 centimeters. So what can you understand from the graph? Okay, what can you understand from the graph? It is a straight line graph. Yes or no? It is a straight line coming from the origin. What does this show? That the marble was moving in a uniform motion. Do you understand? Also, now we have to understand how do we know about acceleration just by looking at a distance versus time graph? This graph is just distance versus time. Yes or no? Can you find acceleration over here? Can you find any point where I've written A over here? But after looking at the graph, you can actually have conclusions about acceleration. As you can see, this line is moving up. Okay, this particular slope that is moving up shows that the body is moving in positive acceleration. Do you understand? If the slope was down like this, okay, like parallel to this particular axis, parallel to x-axis, this means the body was going to be at rest. The body was at rest. Do you understand? If the slope moves downwards, this means the body has decreased its speed. Okay, did you get this point? So just by looking at the graph, we can have conclusions of what is going to be the acceleration's nature. How is the acceleration going to be? So what do we understand from this particular readings that we have taken as examples over here? We drew this part of the graph and we understood that the body is moving in positive acceleration. Okay, how do I know that the body is moving in positive acceleration? Because the slope is increasing. As I see this line moving forward and moving up and up, this shows that it is making a greater angle over here. Do you understand? So as the slope increases, the acceleration of the body is also going to increase. Do you understand? Look at the readings. Just by looking at the readings logically, you understand. The body or the marble covered 40 centimeters in 2 seconds, 60 centimeters in 3 seconds. That is a very good change in velocity. Yes or no? This means the body is moving with positive acceleration forward. This means as the slope increases, the acceleration of the body is also going to increase. Do you understand? So for 40 centimeters, okay, if the body has taken 2 seconds, in some other case, if the body is going to take 10 seconds to complete 40 centimeters, this means the acceleration is going below. Okay, there is a decrease in the change in velocity. Do you understand? Because the body is moving slow right now. So this is all logical over here that you need to understand. So let's just sum it up. What did we study in this? We came to know how to make your own inclined plane, and we release the marble at different distances. We have a steel plate that is going to be struck once the marble reaches it, and we are going to record the time. We have 3 different timings over here and we take an average of it. We also find the acceleration. What do we do after finding finding of the acceleration, we are going to compare it. After that, we plot a distance versus time graph. And from the distance versus time graph, we understand that as the slope of the graph is increasing, the acceleration of the body is also increasing. Do you understand? So now instead of a marble, if I take an iron block over here, okay, instead of a marble is round and spherical in shape and it is going to move very easily on the track. Yes or no? It is going to have a natural rolling motion in it. But what about iron block? Is the iron block going to move as smoothly as the marble? No. It is definitely going to take more time as compared to the marble. Do you understand? So acceleration of the iron block is going to be lesser than that of the marble. Did you understand? This is what we conclude from this particular topic, that as the slope of the graph is increasing, the acceleration is also going to increase, and acceleration is going to be different for different substances or objects depending on the nature of the substance. Do you understand now? Now let's move to the next part of the chapter. So we are on page number 26 now, and with example number 1, let's do it together. Hope you have a pencil and a rough book in your hand and also the textbook open. So I will be reading it out as well as you. I want you people to listen what am I reading and also try to understand what I'm trying to explain you. So yes, example number 1 class. A car is moving with initial velocity 15 meters per second. So how do you write initial velocity? U is equal to 15 meters per second. Okay, so now car stopped after 5 seconds by application of brakes. So what is 5 seconds over here? 5 seconds is the time given, time taken by taken by the car after the application of brakes. So whenever they are going to mention brakes in the question, this means they are talking about negative acceleration. What is negative acceleration? Also called as deceleration or retardation, and it is also always going to be minus. Do you understand? So let's see. The time given over here is 5 seconds. So they are asking us to find the retardation. See, in the question itself they gave you a hint. Find the retardation means find the negative acceleration or find the deceleration. So acceleration is equal to question mark. So you have initial velocity with you, you have the time with you, you need to find out what class, you need to find out acceleration. Is the final velocity given to you? No. How do you denote final velocity as v? So v is going to be taken as 0. You are going to consider the equation v is equal to u plus at. So v is equal to 0, u is given as 15 over here, plus a is yet to be found out, and t is given as 5. Do you understand? That is what is done over here. Okay with everybody? So now 15 is taken on this particular side. When I take 15 on this side, plus 15 becomes minus 15 is equal to 5a. I want to find out the acceleration. So minus 15 by 5 is equal to a. This can also be written as a is equal to minus 15 by 5. 5 ones are 5 threes are. So minus 3. So let's look at this. So acceleration is equal to minus 3, and what will be the units of acceleration? Meters per second square. So if you don't remember what are the units, you can definitely write along. Okay, so this 15 over here is nothing but meters per second. So you can write meters per second over here. The time is 5 seconds. You can write seconds over here. It is meters per second square. Now do you understand? Meters per second square. Okay with everybody? This s is going to come in the denominator. S into s is nothing but second square. This is how you write it. Now the next part. Example number 2. A bus is moving with initial velocity of u meters per second. Okay, right now they have not actually mentioned the correct value of initial velocity. They've only told you u, and they're going to tell you how to find out u. Okay, after applying the brakes, they have mentioned brakes. So which kind of acceleration? Positive or negative? It is negative. What is negative acceleration also called as? Deceleration or retardation. Yes. After applying the brakes, its retardation is 0.5 meters per second square. So here in problem number 2, acceleration is given as minus 0.5 meters per second square. Why did I write minus? After looking at the keyword brakes. Okay, and it stopped after 12 seconds. So time is also given as 12 seconds. So now find the initial velocity and the distance traveled by the bus after applying the brakes. So now you need to find out u. U is equal to a question mark, and they're also asking you to find out the distance. So let's try to understand the question first. A bus is moving with a certain velocity and it is going to apply the brakes. Okay, after applying the brakes, it stopped after 12 seconds. Do you understand? And what do you need to find out? You need to find out the velocity at which the bus started moving and the distance it traveled after applying the brakes. Do you understand? You are going to find out the velocity at which the bus started to move, and you're also going to find out the distance traveled by the bus after applying the brakes. After applying the brakes, the vehicle moves to a certain distance. Yes or no? A little bit of distance. You're going to find that. Okay, this is, I know, a bit clumsy, but we are going to try to do it. It is going to be very simple. Don't worry about it. Okay, so the things that are given to us, the data that is given to us is acceleration is 0.5 meters per second square. Time is given as 12 seconds. What is this time over here? It is nothing but the time taken by the bus to stop after applying the brakes, and the initial velocity and the distance need to be find out. What is going to be the final velocity? It is going to be 0. Okay, so now we are going to continue over here. So now v is equal to ut plus, okay, instead of this, v is equal to u plus at. Okay, so let's look at this. First, we are going to find out the initial velocity. The final velocity is 0 over here. U needs to be find out, and acceleration is nothing but minus 0.5 into 12. Okay with everybody? So u minus 12 into 5 is 60. So it is 6.0 because we have a point over here, and it is 0 again. So u is nothing but 6 meters. Let's look at the values over here. Yes, it's 6 meters per second. So initial velocity, we found it out to be 6 meters per second. So half of the question is solved. The next half of the question is asking you to find out what is the distance traveled by the bus after applying the brakes. So for the distance, you are going to use the equation. S is equal to ut plus half at square. Do you understand? Because given in a textbook also, if you are getting confused, where did we get these equations from? We got these equations from equations of motion, the previous video. Okay, so here S is equal to U is nothing but how much class? 6 into how much is the time given as 12 plus half into the acceleration is given as minus 0.5 into t is given as 12 square. Okay, 12 square is 144. Okay, fine class. So here, so I'm going to continue over here. Okay, the initial velocity is 6, time is given as 12, acceleration is given in the question as 0.5, and we know it is minus 0.5 because it is deceleration. T is given as 12, so t square is 12 square. So now we are going to further solve the problem. 6 into 12 is nothing but 72 plus 1 by 2. Now we have minus 0.5 into 144. Do you understand? So S is equal to, now we need to find out this particular portion. So 144 into 5. So 5 fours are 20, 5 fours are 20, carry over 22. So 5 ones are 5, 6, 7, and we have 0 point, right? So 72.0. So this is going to be 72 plus 1 by 2 minus 72. Do you understand? So 2 ones are 2 threes are 6, 2 6 are 12. It is minus 36. So S is equal to 72 minus 36. 72 minus 36 is nothing but 36 meters. What is this 36 meters? This 36 meters is the distance traveled by the bus after applying the brakes. In how much time? In 12 seconds time. Do you understand? Okay, so this was the problem. So for now, if you want me to talk about it again, example number 1, I'll just explain the question again. There is a car which is moving with an initial velocity, and the car has stopped after 5 seconds after the application of brakes. You just need to find out the acceleration in this case. Do you understand? There was a car which was moving with a certain velocity, and it applied the brakes. And after applying the brakes, it still moved for 5 seconds and then stopped. So in this case, you had to find out the acceleration or the deceleration, negative acceleration. In the second example that I explained you over here, there is a bus which is moving with an initial velocity, and it has applied brakes, and after applying brakes, it stopped after 12 seconds. Do you understand? And after applying brakes, the acceleration calculated for this was nothing but minus 0.5. Do you understand? Because it was negative acceleration. And after applying the brakes, the bus still moved for 12 seconds and then stopped. So you need to find out how much distance did it move in those 12 seconds. And how much distance did it move in 12 seconds? It was 36 meters. Please go through these two problems and practice them. Okay, the rest of the two we will do in the next video. For now, I will write down the Sakshi as well as read it out for you if you are not able to see. Okay, so the classwork done was from page number 25 and 26, which also had the problems done, and homework is to practice the problems. Practice the example 1 and 2. Okay, so now classwork is page number 25, 26 done, and then we have the homework, which is nothing but you need to practice example number 1 and 2. So we will do the further examples in in the next video, but you can definitely try doing example number 3, which is similar to example number 2. It is very easy. I want you to try it, example number 3. Okay, that's all for this video. Thank you.